Today, you're gonna learn how to make these do whatever the heck you want. Welcome back to my Arduino tutorial series, where it's time to learn the basics by coding some LEDs. But first, what is an LED? Well, LED stands for light emitting diode, so it's a diode that emits light. Okay, that doesn't explain much. So a diode is simply a component that allows electricity to flow through in one direction, but not the other. Normal, non-light emitting diodes usually look like this, and will let current flow this way, but not that way. But how does an LED make light? This is actually very cool. So, in simple terms, inside an LED is a union of two types of semiconductors, a positive or p-type one, which wants electrons, and a negative or n-type one, which wants to release electrons. When current is passed through this p-n junction, electrons from the n-type semiconductor are allowed to flow to the p-type semiconductor. The thing is, as this is a state of lower energy for the electrons, they release the extra energy in the form of light. Now, the color of the light depends, of course, on the wavelength, i.e. the energy, of the photons, which depends on how much energy it took to excite them out of the n-type semiconductor. This in turn depends on the material. So for red LEDs like this one, we usually use aluminum gallium indium phosphide. So it's not just that it has a red cover. Anyway, enough of the science class, let's get this working. But to do that, you're gonna need to know what each thing on the board does. So whatever you want to try with an Arduino, you do it through these pins. We're gonna ignore most of them for now. The important ones are these labeled from 0 to 13, which are the ones you can control, the G and D pin, which stands for ground, basically negative, and the 5-volt pin, or just the positive. So now plug your Arduino into your computer through the USB cable. To turn on an LED, all we really need to do is connect its positive leg, which is the long one, to 5 volts, and its negative leg, the short one, to G and D. Except never do this. LEDs don't need that much power and they will blow up. Instead, we need to add a resistor to the circuit, which will lower the voltage and current to an acceptable level. Resistors are rated in ohms. The higher the ohms, the more resistance. I personally like to use 220 ohm resistors. But how do we connect this now? Well, here's where our breadboard comes in. A breadboard is a really handy tool which allows you to easily make circuits without having to solder. On the inside, this is how its holes are connected. It has these long lines at the sides which can act as common 5 volts and ground rails. So what we'll do is connect 5 volts to the positive rail and GND to the negative rail. So now all of this is charged positive and negative respectively. Now, choose two holes to insert your LED. Doesn't matter which, just make sure they're on different lines. And keep in mind, the long leg will be the positive and the short leg is for the negative. Now, if you take a resistor from the 5-volt rail to the positive and connect the ground rail to the negative, the LED lights up. But 5 volts isn't cool, it's just always on, we want to be able to code it. And to do that, we'll use these pins I mentioned. So let's get rid of the 5 volts, get a jumper wire from any pin, I'll choose pin 4, do some line, and then connect that to our LED's positive through a resistor. And that's our wiring done. Now let's open the IDE. So as we saw last time, this is what you'll see whenever you open the IDE. And as you can see, it actually already gives you two things. This void setup thing and this void loop thing. Now what are these? So as it says in these comments, so whenever you write two slashes and then any text, all that line will be turned into a comment, so it won't affect the code. It's quite handy when you wanna, give these kind of instructions. But anyway, these two blocks, this void setup block will run once, as it says here. So whenever you run your code, this will run at the beginning only once. So whatever you write here, yeah, that'll happen to it. And then this whatever you write in this void loop thing will run after the void setup, repeatedly, forever. It will just run in a loop. That's why it's called void loop. Yeah. And so yeah, that's basically it. You also sometimes write stuff like on top of this, like usually when you're introducing variables and including libraries, you usually do it on top, outside of these blocks, but we'll get to those later. But for our case, what we're gonna do is code our LED. So what do we need? Our first command will be pinMode. So pin, all in lowercase, uppercase M, and then the rest, mode. That's pretty important. It's case sensitive, so yeah, make sure you get that right. So what does pinMode do? pinMode, what it does is basically indicate to our program what each pin is going to do in our code. So which pins we're going to use and what their function is. So in my case, I chose pin 4, so I will do 4, comma, and then we need the pin mode, the function of our pin. There are two main types of functions, input and output. Input will be for when we have like sensors, basically stuff that's taking data into our system or signals into our system. And output will be when we are sending signals to components like actuators, say LEDs, motors. So for our case, of course, it will be output because we're gonna be sending a signal to an LED. And now, very important, this is the most common mistake in Arduino, like in general. I even make it by myself every once in a while, but well, even once per script basically. Semicolon at the end. Every time you want to write one of these commands, semicolon at the end. If you don't, try and check it, and it's gonna be wrong. Luckily the message is quite descriptive, it says expected semicolon, but still, you're probably gonna make this mistake so much. And yeah, it'll take some time to get it into your head, but anyway. So yeah, that's that. That's what we're gonna write in our void setup. So yeah, because we only need to establish our pin modes once, it wouldn't make sense to put it in the void loop. So in our void setup, we've got our pin modes. So we're saying that we're going to use pin 4 as an output pin. And we don't really need to write anything else here. Let's go on to void loop. So in void loop, what we're gonna write is our next command, which will actually send the signal to our LED. And it's gonna be digitalWrite. So what digitalWrite does is it takes a pin, in our case 4, and it sends it a signal. And it can be a high signal or a low signal. Also, I'm not writing this in, well, as I said, it's case sensitive, so always make sure you write these things in uppercase. So a high signal means on, and a low signal means off. Pretty simple, it's basically the simplest command you can find out there. So if we want to turn our LED on, we just write high, and this will send an on signal to our LED. So digitalWrite is basically the on-off command, basically. It's really simple. Semicolon at the end, of course, and let's upload it. So we hit upload, it'll now compile the sketch, upload it, and if you did it right, you should see your LED light up. But let's take this a step further, because this is basically like what we did with 5 volts. This is boring. So what we're gonna do is make it blink, for example. And here's where our third command comes in, the delay command. So delay is basically like a wait command. So if you put, say, delay 1000, it'll wait for 1000 milliseconds, which, if you went to math class, is 1 second. Semicolon. Then, so yeah, this will just turn our LED on and wait for 1 second. But then nothing will happen. So what we're gonna do is digitalWrite our pin low. So after 1 second, it's gonna turn it off. And then we're gonna do another delay, and you'll see why now. Say another second. You can actually write whatever you want. Say 386, and here 946. But no, cool. So yeah, what it'll do now is turn our LED on, wait for 946 milliseconds, turn our LED off, wait for 386 milliseconds, but then remember that this white loop runs repeatedly. So it'll come back here, turn our LED back on, off, and we now have a code for a blinking LED. But now let's do a little experiment. Let's set this to 1 millisecond and this to say 10 milliseconds. So it's gonna be on for a tiny amount of time and off for also a tiny amount of time, although it's gonna be off 10 times longer than it's on. But now let's upload this, and it's actually going to be turning on and off so quickly that you won't be able to see it. So look at your LED now and tell me what you see. If you did it right, you should be seeing your LED constantly on, just dimmer. And what we actually did is a technique called pulse width modulation, PWM. So you basically send really quick signals, and depending on the ratio between the time it spends on and the time it spends off, the effect you're gonna see is actually the LED simply being brighter or dimmer. So the longer it spends on with respect to the total time, it will be brighter, and if it's on only a tiny amount of time compared to the time it's off, you'll actually just see it dimmer. And there's actually a command which does this for us, and it's called analogWrite. So in contrast to digitalWrite, which just has high or low, analogWrite, which also takes a pin, so in our case pin 4, instead of taking high or low, it will take a value from 0 to 255. And this actually applies not only to LEDs, but to basically any component. And you'll see later how incredibly useful this command is, because you can just send basically varying signals. So it's literally a level signal, a power level. So yeah, it's an incredibly useful command, except this will not work. As things stand, this will not work. Why? Well, first because I forgot the semicolon. See, I told you. I keep making that mistake myself. Because only some pins support PWM, and pin 4 is not one of them. So if you just look at your Arduino real quick, you'll see that some pins have a little squiggly line after the number, what it's called a tilde. And those are the pins that do support PWM, so the analogWrite command. So if you chose a pin that doesn't have a squiggly line, like I did, just change it to some other one, say pin 6. And if you happen to choose a pin with a squiggly line, then you can just use that one. So if you did need to change your pin, make sure to just rewire your pin to use that one instead of the one you chose, and then upload your code. So your LED should be on now, and as things stand, this will actually do the exact same thing as we were doing with our digitalWrite command, because 255 means that of every 255 units of time, it'll be on for 255 units of time. So it'll be always on. It's right now it's basically not oscillating. But if we set it to say half of that, for example 128, then you'll see it should go down to half brightness. There we go. And if you set it to say, I don't know, 50, it should be on for only about 1/5 of the time, so it'll be at 1/5 the brightness. You can also set it to 10, and it'll be basically off, because out of 255, it'll be on 10, 10 time units. So yeah, with this, you can modulate your power level, and if you want to see it change, you can actually paste a bunch of these and just set it, say, 50, and then I don't know, 100, no, 1,000, another 1,000, and then 200, and then 255. Let's add a delay of, I don't know, 200 milliseconds between them. There we go. And now, if you upload this, you should see, oh, forgot one delay, there we go. If you just upload this, you should see your LED increase in brightness in a loop, and then go back to, the original brightness. Yeah, you should see a cool light animation already.
Tired of your LED showing a sense of identity? Would you like to change not only the brightness, but also the color of your LEDs? Well, I know exactly what you need. I present to you RGB LEDs.
The way RGB LEDs work is they have 3 different LEDs inside. A red one, a green one, and a blue one. And guess what? That's why they're called RGB. And by mixing different amounts of light from these LEDs, they can make any color in the visible color spectrum. And that's why they have 4 pins. A ground pin, like for normal LEDs, and then 1 pin for each LED, red, green, and blue. Now, to wire the RGB LED, we need to keep in mind that the longer cable will be G&D this time, and the shorter cable on one side will be the red one, and the 2 shorter cables on the other side will be, in order, the green and blue ones. Now, I'm just gonna connect G&D directly to it this time, and then we need to choose 3 pins. But you need to make sure that they are PWM pins, because remember, we're gonna be using analogWrite commands. So, for me, I'm gonna choose 3, 5, and 6, for example. So yeah, I'll take them to the line on the other side, because now, remember that we need to connect them through resistors to the lines where the LED is connected. So we're gonna need 3 resistors. And once we've got that, our wiring is complete. So, to code an RGB LED, it's actually really simple. It's basically just like coding 3 separate LEDs, the red one, the green one, and the blue one, and make different combinations of them with the analogWrite command to make all our colors. So that means we're gonna have 3 pin modes. So in my case, I chose the pins 3, 5, and 6. Output, of course, because there are LEDs. So I'll just do this 3 times. And 5 and 6. So that'll be all our pin modes. As you can see, it got indented. That's basically just for presentation. Like in Arduino, indents just do not matter. In fact, not even lines matter. If you wanted to, you could just make it all in a single line of code. So yeah, if you want to, just go crazy, do whatever you want. But anyway, so in our void loop, to make our colors, if you don't know how the RGB system works, you can check online tools, and you can actually see those sliders, and you can see how the different combinations of colors give different results. And it's actually really useful because they are already in the 0 to 255 range that analogWrite uses, because it's 4 bits, you know. But anyway, we'll use 3 analogWrite commands, 1 for each LED. So for our red color, we're gonna just start making white, for example. So we'll just set all of them to 255, the maximum, and that should give us white. So 3, 5, and 6, all to 255. Oh, semicolon, there we go. Keep making this. All to 255, the maximum. So if we just upload this, this should give us a white color in our RGB LED. Now, if you want to make, say, red, well, you go like this. So full red, 0 green, and 0 blue. If you wanted to make, I don't know, orange, well, full red, say half green, and 0 blue. If you wanted to make yellow, full red, and full green. Then if you want to make, I don't know, green, well, just full green and everything 0. If you want to make cyan, well, full green, full blue, and there we go. Alright, now blue, well, the same thing applies, full blue. And if you want to make purple, or well, more like pink, I think it's gonna be, you can just do this. And in fact, if we just add a little delay here, say 200, let's put it in between all of those. That looks ugly, but indents don't matter, so I don't care. There we go. If we just upload this now, we should have a little rainbow animation. And well, granted, you don't really need to do fully red here, for example. You could do just like 100 and it would be a dimmer red. And yeah, same thing here. You could just do 145, or I don't know, 45 and 45, or you could, you can just do whatever mixture of whatever weird mixture, not that one, mixture of colors you want. So yeah, you can now make whatever color you want.
So that was Arduino 101 using LEDs. Keep fiddling around and having fun with what you've learned. And if you appreciate these tutorials and want me to keep making them, please make sure to like and subscribe, and stay tuned for the next episode where we'll be learning to code buzzers, which are just so much fun. So, see you then!